Hello there and welcome back to the Science Sleepy Minds. You're floating now, gently, soundlessly, through a dark that isn't empty. Stars blink at you like slow thoughts forming, their distant pulses soft enough to almost lull you under. The universe stretches around you like a great wool blanket, but with pinholes that shimmer. You're not flying exactly, just gliding along the weave of something much bigger than you. Your heartbeat slows, but here's the catch. What if the universe you're floating through isn't the whole thing? What if this cozy infinity is just one speck, one cell, in a much vaster organism? A cosmic matryoshka doll. A living lattice of realities stacked in scales we can barely begin to imagine. You're inside the universe, sure, but the universe might be inside something else. You probably won't survive that particular reality check, so before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And let me know in the comments, where are you watching from tonight, and what time is it there? I want to know how far this sleepy little thought experiment is travelling. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You trail your fingers along the edge of nothing to understand this strange, almost heretical idea that our universe might be just one cell in a greater structure. You have to first let go of the idea that the universe is all there is. Not in a philosophical sense, but in a literal spatial one. Imagine zooming out from Earth, past the Moon, past Mars, past the outer glow of the Kuiper Belt. You drift beyond Voyager 1, past the Oort cloud where the sun becomes just another dot. Still zooming, galaxies pull back into a bright spray, the filaments of dark matter web out, the cosmic microwave background wraps everything in a baby blue mist of origin, and yet, you zoom further. At some point, shouldn't there be a wall, a last star, a final pixel? Well, depends on who you ask. Historically, humans hated this idea of infinite space. Ancient Babylonian cosmology pictured the universe as a bubble encased in a firm dome. The Egyptians thought the sky was the stretched body of a goddess. Even Aristotle, thoughtful and precise as he was, envisioned a finite universe wrapped in concentric crystal spheres, each holding a planet like a marbled gumball. It's almost charming. But these views didn't die quietly. Even now you can find versions of the enclosed universe theory, dressed up in sci-fi suits or holographic jargon. They're no longer literal domes, but the question remains, is there an edge? If so, what's outside it? Some physicists argue that the universe might be closed like the surface of a sphere. You could travel forever without hitting a wall, looping endlessly. Others suggest it's open, expanding forever into who knows what. And then there are the fringe thinkers, those who whisper that we might be sitting inside a cell membrane of some higher dimensional organism. Yes, like a literal cell. A bubble inside a living being so huge that the stars are just organelles, and galaxies little mitochondria crunching out bursts of gravitational ATP. Of course, historians still argue whether early Gnostic sects actually believed in a nested cosmos, worlds within worlds, like spiritual Russian dolls, or whether that was a later interpretation layered in by overly poetic scholars. Still, it's fun to imagine a cosmology where reality itself is a layered thing, and we're somewhere down near the subcutaneous fat. What's more, there's an eerie precedent for it. You see, in biology, cells cluster to form tissues. Tissues bundle into organs, organs into bodies. And if you're feeling especially introspective tonight, maybe you've already wondered, what does the body of the universe look like? You drift through these thoughts like dust on a sunbeam. Somewhere deep in the void you imagine a greater structure, immense, slow, and pulsing. Maybe it's made of other universes. Maybe they branch like capillaries, or spore off like fungal nodes in a mycelial network. And maybe our little cosmos is just the blink of an eye to that structure, a thought, a hiccup. Of course, we don't have telescopes strong enough to see outside the universe, but that hasn't stopped people from imagining, In the mid-20th century, physicist André Linde would help pioneer a theory that the universe we see might just be one bubble in a grand multiverse. And more recently, some cosmologists have taken things further, wondering if these universes interact like cells in a tissue, exchanging information or energy at their membranes. Maybe that's what dark matter is. Maybe that's what déjà vu is. Maybe the Big Bang was just cellular mitosis. Now that's a stretch, but it's a beautiful one. You let that sink in. The idea that your universe, everything you've ever seen, every science textbook, every memory, might be the equivalent of a single red blood cell in a being too vast to comprehend. It's humbling. Comforting too, in a way. Because if we're just a cell, maybe we belong to something. Maybe we're part of a function. Maybe we have a role. And if we do, does the cell know it's a cell? You wonder about that. About consciousness, about scale. Your body is made of trillions of cells, most of which are completely unaware of you, but they act in harmony, they pulse, they divide, they die and are replaced. They make you possible. So what if you are making something possible too? Quirky, right? There's even a short-lived 1970s theory. Don't ask who started it. It was likely a fringe pseudoscientist with too much free time and not enough peer review, that suggested each atom was a universe unto itself. Infinite recursion, macro in the micro, micro in the macro. But still, it stuck. Because it feels true in the same way dreams feel true. Softly, irrationally, and only until you say them out loud. Right now, you don't need to say anything out loud. You just need to float. Let yourself spiral slowly through this idea. No need to solve it. Let the silence stretch around it, like gauze around a sleeping thought. One universe, one cell, maybe. You're still floating. It's darker now, not pitch black. More like the inside of a deep-sea creature's belly. There's a glint here, a curl of light there. The kind of darkness that feels thick, like velvet or warm fog. But you're not scared. Just suspended, and your thoughts are starting to feel stranger. Because now you're thinking, what does it even mean to say everything? You've used the word 1,000 times. Everything I have, everything we know, everything in the universe. But if your universe is only one cell in something else, then everything was always just shorthand, like a toddler calling their bedroom the whole world. And here's the weird part, scientists have started asking the same thing. You remember that guy who first dared to say Earth wasn't the centre of the universe? Copernicus, sure. But the real drama came with Giordano Bruno, who said, maybe, just maybe, the universe has no centre at all, that it's infinite, that there are other suns, other Earths, other realities. The church was not thrilled. Spoiler alert, Bruno didn't survive the fan mail. Still, he was onto something. Because once people started accepting that Earth was just a rock in a galaxy, and the galaxy was just a streak in the sky, and the sky was actually full of galaxies, well, the door to bigger than everything creaked open. And now, you're standing in that doorway, or rather you're drifting in it, like a dust mote in a cathedral. Mainstream physics has reluctantly begun to flirt with the idea that the universe isn't singular, not the only show in town. Enter the multiverse. A term that sounds like a video game setting but is actually a series of hypotheses about reality branching, bubbling, or stacking on top of itself like a badly coded sandwich. But what if we move past multiverse into something even more unnerving? A structure, something with layers, something where your entire cosmos is one cell in an organism, not metaphorically, but functionally. You're not just inside the universe, you are the universe. But the universe is inside something else, which means technically you're inside that too. Take a breath. Or don't. There's no air out here. Let's play with that thought. If the universe is a cell, what kind is it? A neuron? A blood cell? A skin cell in some alien epidermis stretching across dimensions? It sounds wild. But here's a bizarre truth. Some cosmologists and physicists have already noticed the parallels. Zoom out on the cosmic web, those vast spider-like filaments of galaxy clusters, and it starts to look like brain tissue, a cortical network, the structure of your own mind, just much bigger. There was a 2020 study actually where an astrophysicist and a neuroscientist compared the large-scale structure of the universe to the human brain. They found that the number of connections between galaxy clusters and the patterns of synapses in a brain were suspiciously similar. Not identical, of course, but weirdly close, considering the scale difference is, about 27 orders of magnitude. You let that number roll around for a second, that's a trillion times bigger, and yet similar. Historians still argue whether early Renaissance mystics were inspired by this kind of recursive thinking when they drew the famous microcosm and macrocosm diagrams, human bodies inside cosmic wheels, each part of the body echoing a planet, a star, a zodiac. But whether that was spiritual metaphor or proto-science, the itch is the same. What if we're not just in the universe? What if we are its function? You pass a cluster of stars now. They shine like fireflies in molasses. A few of them wink out and reappear as if breathing. You wonder if, just maybe, you're watching synapses fire. Somewhere out there, a universal thought completing itself. And that brings up an even weirder possibility. If the universe is a cell, and all the cells are part of something else, then, like any good biological system, could there be communication? Is information being passed from one universe to another? Through membranes like hormones? Through wormholes like cosmic nerve fibers? No one knows. Yet. But in theoretical physics, the questions are being asked. Because the math doesn't always stop at one universe. In fact, it rarely wants to. You keep getting residual terms, wiggly leftovers, constants that suggest the equations are reaching past their cages, trying to hint at something beyond the border of space-time. It's like trying to stuff a sleeping bag into too small a sack. The universe keeps puffing out, maybe because there's more of it than we think. There's even a rogue theory, half joke, half journal paper, that suggests black holes might be storage nodes, memory capsules. And if black holes connect universes, maybe they're not just garbage disposals. Maybe they're neurons. You take another drift. Slowly now, letting the thought land like a feather. If your universe is a cell, what's its lifespan? Cells grow. They divide. Sometimes they mutate. Do universes do the same? If so, are we a healthy cell? Are we cancer? Don't panic. The point is not to get lost in answers, it's to feel the size of the question, to sense how big the structure might be, and how small, but still strangely precious, your speck of reality is within it. Your bones stretch with the chill of the idea that this vast everything you call universe might just be an ingredient, a unit, a brick in a wall you'll never see. And who built it? That's a different conversation. For now, it's enough to wonder, if we are a cell in a larger organism, maybe we're not alone. Maybe that structure is teeming with other cosmic cells, other universes, each with their own rules, their own physics, their own brief, blazing stories. Maybe one of them is looking back at you right now. You smile, or something like it. There's time to keep drifting. You float a little slower now, as if the vacuum itself has thickened, tugging gently at your limbs like warm honey. Somewhere behind you, if behind even means anything anymore, your home universe pulses like a faint lighthouse glow, but your attention turns forward, or outward, or, let's just say, next, because tonight you're heading toward a wall. Yes, a wall, or at least the possibility of one. The idea that maybe, just maybe, your universe has an edge, a border, a place where the fabric of space-time folds into itself or ends. Not a hard brick wall, mind you, more like the edge of an old film reel, something flickering, something final. It's a question that's haunted thinkers for millennia. Ancient Greek philosophers debated it in togas with sandals and scrolls. Some, like Archytas of Tarentum, posed a brilliant little paradox around 400 BCE. He asked, if I were at the edge of the universe, could I stretch out my hand? If yes, then the universe must go on. If not, then what's stopping my hand? And you, sleepy traveller, stretch out your hand now, half playfully, half philosophically, and wait for the edge to slap your palm, or it doesn't. But that's kind of the point. In modern cosmology, the edge question gets even stickier. Our observable universe has a boundary. Sure, it's about 46 billion light years in every direction. That's the limit of what light has had time to reach us since the Big Bang, but that's just the observable part. The rest? Unknown. Possibly infinite, possibly not. Some models suggest the universe is like the surface of a balloon, finite but unbounded. If you walk in one direction long enough, you'd loop back to where you started without ever hitting a wall. Of course, that assumes a positively curved, closed universe. Others say it's flat and infinite, stretching on forever in all directions. And then, of course, there are the juicy alternatives. What if the universe has a real physical edge? Not an abstract mathematical border, but a literal limit to its expansion. Something beyond which there is nothing. Not empty space, not vacuum, just non-being. Like the way a video game map stops rendering once you walk too far. Beyond the border, no textures, no code, just void. Even Einstein had a moment or two staring at the equations, wondering whether the universe loops or ends. He leaned toward a closed, finite model early on, though the idea of a static universe, unchanging and eternal, was his vibe until observations of redshift shattered that comfy illusion. Historians still argue whether Einstein privately resisted the idea of an expanding universe because it conflicted with his philosophical aesthetic, or whether he genuinely mistrusted the data. Either way, the edge creeped back in through the cracks, and now you drift closer. Imagine reaching the edge of the universe. The very last galaxy cluster twinkles behind you like a dying ember. In front of you, a shimmer, a limit, not a wall you can touch, but a slow fizzing of structure. Space-time losing coherence, light bending strangely, the cosmic microwave background wrapping around you like the closing act of a very elaborate play. You're not supposed to be here, but this is where it gets deliciously weird. Some modern theories, especially those born out of brane cosmology and string theory, suggest that if there is an edge, it might not be the end at all. It might be the beginning of something else. Picture this. Our universe isn't a lonely balloon. It's a soap bubble floating in a higher dimensional fluid, and near the edge of that bubble, the membrane is thin, permeable, and just maybe, brushing up against another bubble, another universe. You imagine two bubbles kissing in the dark. That soft contact could transfer energy, or birth a new universe entirely. Some physicists even speculate that the Big Bang, the beginning of our universe, was triggered by a collision between two such branes. Like a clap, a cosmic slap, and boom, here we are. Of course, this raises a question that's both exhilarating and terrible. If the Big Bang happened from outside the universe, what else might come from out there? Is it still happening? Could another brane touch ours again? Would we even notice? Or would everything just vanish like a hard reboot? Sleep tight with that one. You pass close to what looks like a cosmic tear. Just an image your drifting mind conjures up, of course, but convincing in its elegance. You picture space-time stretching too thin, like old plastic wrap. And beyond it, a colour your eyes can't process. A movement that doesn't obey causality. If the universe has a wall, it might not be a barrier, it might be a threshold. Now let's get a little poetic. In 1884, Edwin Abbott wrote Flatland, a satirical novella where two-dimensional beings try to comprehend three-dimensional space. To a square, a sphere looks like a circle that appears, grows, then shrinks away. That's how it enters their universe, through a dimensional lens they can't fully perceive. You, listener, might be a 3D being watching a 4D object brush past. What would it look like? A UFO? A religious vision? A glitch? Maybe what we call the unknown is just the universe brushing against its own boundary. And boundaries, as you know, can be crossed. Let's dip into something quirky now. In 1957, Hugh Everett III proposed the many worlds interpretation of quantum mechanics. According to this, every quantum event creates a new branch, a new universe. And while most scientists treat this as a theoretical curiosity, a few take it very literally. They suggest that the universe might be constantly budding off new realities at the edges of possibility, like cells dividing at the borders, a kind of quantum mitosis. If that's true, then the wall you're drifting toward, it's not a fence, it's a bloom, a place where new universes are being born every Planck second, each one drifting off with a slightly different version of you. One where you became a baker, one where you never sent that text, one where the dinosaurs didn't get the memo about extinction. You smile, not because it's all true, how would you even know, but because it's possible. And in the dark, possibility is its own kind of lullaby. So here you are, at the almost edge, the end that might be a beginning, the border that maybe loops or bursts or bleeds. You reach out your hand again, and this time you don't expect to touch anything. Because some boundaries aren't meant to stop you. They're just there to remind you there's more, always more. You're drifting again, slower this time. Not because anything is pulling you back, but because the fabric of thought itself seems to stretch thinner out here. Each idea takes longer to form, like a ripple through honey. You're not just contemplating the edges of the universe anymore. You're beginning to see patterns, repetitions, echoes. And then it hits you. The universe feels fractal. Yes, that strange recursive geometry you see in snowflakes and broccoli. That repeating dance of shapes within shapes, self-similar and infinite in complexity. It's as if the cosmos has written itself using the same pen at every scale. The thought settles in your mind like a whispered riddle. Is the universe just a repeating structure? It might sound poetic, but there's serious science behind this. In fact, for decades, researchers have examined whether the distribution of galaxies follows a fractal pattern. Not perfectly, mind you, but intriguingly close. You start to picture it. Clusters of galaxies strung along vast filaments, which branch into smaller threads, which host solar systems, which contain planets, which swirl with weather systems, which harbour living cells, which are made of molecules, which are built from atoms, which hold... well, you get the idea. Each layer is its own little universe, or perhaps each is a cell, or a neuron, or a nesting doll carved in math instead of wood. In the late 1980s, an astrophysicist named Luciano Pietranero proposed that the large-scale structure of the universe might actually be fractal in nature. He and his team found evidence that the distribution of galaxies didn't just smear out uniformly with distance. Instead, it formed complex self-similar structures, not randomness, not order, something in between, a fractal. Historians still argue whether this was ever accepted by the mainstream. Many cosmologists dismissed it, saying that the universe becomes homogeneous at large enough scales. But the idea never truly went away. Because the pattern, it's seductive. You're suspended now in that pattern. You imagine zooming out and seeing it, not from within, but from outside. A vast, pulsing web of light, repeating its design endlessly inwards and outwards. The shape of a spiral, a Mandelbrot set of galaxies curling at the edges of space and time. And what if that's not coincidence? Here's where things get extra wobbly. Some theoretical physicists have toyed with the idea that reality is scale invariant. That is, the laws of physics might operate similarly at different scales. Gravity, quantum behaviour, electromagnetic forces, they echo across levels, and maybe that's why the universe feels fractal. Think about lightning bolts and river deltas, blood vessels and mountain ranges. They all follow branching, recursive patterns. So why wouldn't the universe? You drift through a swirl of galaxy clusters now. Their light is soft and distant like candles in another room. Each node in this great web is separated by millions of light years, but somehow it all fits together. It doesn't feel like chaos. It feels designed. Not in a religious sense, more in the way a crystal grows, following simple rules that yield astonishing beauty. You remember those old computer programs from the 90s? Generate a mountain with a few lines of code, fractal terrain, infinite detail from finite input. Maybe the universe did the same thing. Maybe it's a compression algorithm writ large. Or maybe it's the ultimate self-replicating structure. Let's go weirder. There's a niche theory, a beautiful, mostly forgotten idea from the early 2000s, that the universe might not only look fractal, but behave fractally across time. The argument was that major cosmic events, galaxy formation, planetary emergence, even biological evolution, might follow repeating patterns, just at different scales and speeds. Sort of like cosmic déjà vu. You smile now because your own life has echoes like that. Patterns you keep repeating. Decisions you make again and again, under different guises. It's not so crazy to imagine the universe doing the same. After all, it made you, didn't it? There's a whisper of another question beneath all this. If reality is fractal, what does that say about boundaries? Do they really exist? Because in a true fractal, zooming out doesn't lead to a bigger picture. It leads to the same picture over and over, just dressed in new scales. And zooming in, more of the same. Infinity hidden inside finitude. The universe within a cell within a universe. It's not hard to imagine that if the cosmos is fractal, then what you call a universe might just be a localized recursion, a copy of a larger structure, unknowable only because you're inside it. And maybe, just maybe, that larger structure is alive. Biologists talk about scale-free networks. These are systems that don't have a preferred size. They look similar no matter how far you zoom. Neural networks are scale-free. So are social networks. So it turns out, is the large-scale structure of the universe. Fractals, everywhere. But here's the fringe idea. The one that tucks itself under your pillow at night and waits for your dreams. If the universe is fractal, and if it behaves similarly at every level of scale, then it's not impossible to suggest that entire universes exist inside atoms, and that our universe might be an atom inside something else. Maybe inside a living cell, maybe inside the bloodstream of a colossal being whose entire existence is a slow-motion symphony spanning eons. Of course, there's no proof. No telescope peering into quarks has ever revealed tiny galaxies, but the metaphor remains powerful. The feeling remains uncanny. You drift further now, caught in the spiral of that thought. It's the kind of theory that used to fill late-night forums and university lounges. The idea that your universe is just a fractal copy of something larger. Theories where electrons orbiting a nucleus mirror planets orbiting a star. The scale is different. The pattern, the same. You pass another node in the cosmic web, it pulses, flares, and you can't help but wonder if you just witnessed a cosmic neuron firing. One last thought before you drift. If the universe is fractal, then every cell in your body might contain the entire cosmos. Maybe that's why consciousness feels so vast, why dreams stretch time, why you sometimes wake up with the entire universe echoing in your chest. Because it's in there. Still spinning, still branching, still folding and unfolding itself into infinity. You're weightless now, not just in body but in mind. Thought comes and goes like the tide, gentle and slow with foamy edges. The universe hums around you, low and nearly inaudible, a kind of purring silence. You're suspended in it, caught between questions and galaxies. And just as you start to feel the patterns of fractals settle, something else begins to tug at your mind. A shape, familiar. Not of stars, but neurons. Yes, that tangle of threads you floated through earlier. It didn't just resemble brain tissue, it was brain-like. The same branching, the same clustering, the same eerie symmetry between the cosmic web and your own grey matter. So tonight's question takes one more dizzying step. Is the universe not only shaped like a brain, but thinking like one? You let that absurd little notion swirl for a second, then laugh softly to yourself. Or maybe the universe laughs with you. Who can tell? But let's dig in. Back in 2012, a pair of researchers, Franco Vazza, an astrophysicist, and Alberto Folletti, a neurosurgeon, published a paper pointing out the structural similarity between neural networks in the brain and the cosmic web. They weren't claiming they were identical, but they did note that the way information flows in your brain and the way matter clusters across billions of light years, well, the math starts to rhyme. Both systems, it turns out, balance energy efficiency with complex connectivity. Both form nodes and filaments. Both seem to optimize for signal transmission. And here's the kicker. They even operate with a similar amount of information. That's right. By one rough estimate, the number of synapses in your brain, about 100 trillion, is comparable to the number of galaxies in the observable universe. Some might call that a coincidence, but the longer you drift here, the more it starts to feel like a fingerprint, or a mirror. Historians still argue whether this resemblance was first poetic or scientific. The ancient Hermeticists believed in the concept of as above, so below, that the heavens reflected the soul and the soul reflected the heavens. But today's researchers are less mystical, more cautious. They don't claim the universe is a brane, but they're definitely interested in how much it acts like one. And you're floating in the middle of it, like a signal in the synaptic gap. You reach out, not with a hand this time, but with a thought, a single spark, a wondering. If the universe has a brain-like structure, could it be conscious? You're not the first to ask. Philosophers have tiptoed around that idea for centuries. It's one flavour of panpsychism, the idea that consciousness might not be limited to brains, but instead be a fundamental feature of the universe. Kind of like gravity, but weirder. Of course, this is where things get dicey. Modern neuroscience doesn't even have a consensus on what consciousness is, let alone how to measure it in a galaxy. We barely understand our own minds. Trying to diagnose the cosmos. That's like asking a goldfish to explain Wi-Fi. And yet, there are whispers. One fringe theory suggests that consciousness could emerge from complexity, that once a system becomes sufficiently connected, sufficiently self-referential, it begins to know itself. It begins to feel. You think about your own brain, trillions of connections all firing in waves, patterns within patterns. Most of it you'll never notice, but at the centre of it all, something watches. Something is. Could the universe be watching itself? Could its vast web of galaxies and dark matter filaments form the scaffolding for awareness on a cosmic scale? You pass through another region now, sparse, dim, a few lonely galaxies blinking like porch lights in the fog, and yet they're connected. Gravity ties them together with invisible strands. You wonder, is this how a thought begins? A flicker in the dark. You remember that in your own brain, the space between neurons, the synaptic cleft, is mostly empty too. Just chemicals and potential. Like the gaps between galaxies. Nothing much there, until something leaps. Maybe that's what you're watching now. The mind of the universe leaping between nodes. Here's something quirkier. In 2007, a physicist named Julian Barber proposed a radical idea that time, as we understand it, doesn't really exist. Instead, the universe is made of nows, individual snapshots, like frames in a film. What we experience as the flow of time is just our consciousness moving through these static moments. Now imagine if the universe works the same way, not just in time, but as time. A series of mental states drifting through itself, each now a thought, each supercluster a neuron, the whole thing, one massive recursive brain state. Is that a stretch? Oh yes, but we're far past the safety rails tonight. You begin to consider how information might pass through such a structure. After all, brains don't just hold information, they process it. Is that what dark energy does? Is the accelerating expansion of the universe a kind of signal propagation? A thought reaching its end? You watch a pair of galaxies collide, slowly, like dancers in molasses. Their spiral arms tangle, merge, spark. Stars are born. Gas clouds shudder and shine. If you didn't know better, you'd say you were watching a synapse fire. One of those long, slow cosmic thoughts. And still there's more. Physicists love to talk about entropy, about how the universe is slowly heading toward thermal death, maximum disorder, minimum energy. But what if that's not death? What if it's sleep? You picture the universe not dying but dreaming, curling into itself like a resting giant, its energy not lost but settling. And you? Maybe you're a dream inside that dream, one little firing neuron in the resting mind of something beyond comprehension. Just don't tell your philosophy professor, or do. Depends on whether they've had their coffee. You drift further now, past the edges of metaphor and into something quieter. You no longer ask if the universe is a brain. You begin to ask, what is it thinking about? And maybe the answer is simple. Maybe it's thinking about itself, which means in this very moment it's thinking about you. Your drifting slows to a lull, a hush in the void so total it feels almost liquid, a darkness not of emptiness but of folded depth, like you've stumbled into the crease between pages of a book too large to open all at once. And tonight we slip into one of its stranger chapters. We're diving into string theory now, a place where math gets dreamlike and the fabric of the universe vibrates, not with sound but with possibility. You trail your fingers through space and space hums back. At its core, string theory is a bold proposal that the tiniest building blocks of reality aren't point-like particles but vibrating strings, tiny loops or strands of energy, each with its own frequency. Change the vibration and you change the particle, like plucking a violin string to shift from one note to another. But here's the twist. For the math to work, string theory needs extra dimensions. Not 1, not 2, 10, or even 11. You blink. You've only ever moved through 3 dimensions of space, length, width, height, plus 1 of time. But string theory whispers that there might be 7 additional spatial dimensions, tucked away, curled up so tightly we can't see or touch them, like a hidden room behind the wallpaper of reality. These aren't just theoretical scaffolds. In many versions of the theory, these extra dimensions are necessary to explain the behaviour of fundamental particles. They're not decoration, they're structure, and that's where things get interesting. Because if extra dimensions exist, then the universe you know, this vast glowing ocean of galaxies, might just be a slice of a much larger, higher dimensional reality. You float through that possibility now, and your perception stretches. You're no longer thinking in lines or planes, but in folds and curls. Reality isn't flat, it's woven. And you're just one thread. Now enter Emma theory, a unifying version of string theory that proposes 11 total dimensions. In this model, the fundamental strings aren't just one-dimensional filaments, they can also be membranes, or branes for short, sheets of energy. Some are tiny, some mind-bendingly vast, and some maybe entire universes. Yes. In M theory, our entire universe might exist as a 3-dimensional brane floating in higher dimensional space, like a bubble on the surface of a cosmic pond. You remember earlier when we imagined the universe as a cell? This is where that metaphor gets teeth. Because if our universe is a brane, it might not be alone. There could be other branes, other universes, drifting parallel to ours. They could be a micron away in the 5th dimension, and we'd never know. Just one slight shift in the right direction, one quantum step through a dimension you can't access, and you'd fall through into another world. Historians still argue whether early Hindu cosmologies, which describe the universe as a layered lotus or as an endless succession of expanding worlds, were abstract metaphor or intuitive glimpses into something more. But now, physicists are building equations that hint at the same layered reality. Some versions of M theory even suggest that gravity is leaky, that it might be able to move between branes, while other forces can't. That could explain why gravity feels so weak compared to electromagnetism or the strong nuclear force. Maybe it's being shared between universes, like a cell membrane letting only certain signals pass. You drift slowly now, imagining that shared gravity tugging at the edges of reality. Could the presence of a nearby brane, another universe, create subtle ripples in ours? Some researchers think yes. They've even proposed experiments to detect these ripples, tiny anomalies in gravity that might hint at the presence of a nearby hidden universe. So far, no solid evidence. But the search continues, because if we could prove that another brane exists, well, that changes everything. And here's where the wild stuff begins. In a model called the ekpyrotic universe, a variant of M theory, our Big Bang didn't come from a singularity. It came from a collision. Two branes drifting through higher dimensional space smashed into each other. The result? A sudden transfer of energy, an explosion. The birth of time, space, matter, our universe. Boom! Hello reality. It's a beautiful idea, isn't it? Instead of an origin from nothing, you get an origin from interaction, from contact, from a kiss between universes. But that raises a chilling question. Could it happen again? If another brane drifted close and brushed against ours, would we even see it coming? Would we feel the pull? Or would everything end and begin again in a flash without warning? You float past that thought, letting it dissolve like breath in the cold. There's something poetic about a universe born from collision. It suggests that even destruction can be creative, that even the vastness of space isn't immune to the chaos of touch. Universes might dance, drift, merge, divide, just like cells. You circle back to the structure. If branes exist in higher dimensional space, often called the bulk, then the universe isn't just big, it's embedded. That means everything you know is floating in a larger environment, maybe static, maybe fluid, maybe alive. You pass through a fog of dark matter now. It doesn't sparkle, it doesn't shine, but it tugs at you just the same, unseen but present, like another brane brushing up against yours. And here's a quirky footnote for the dreamers. Some theorists have speculated that consciousness itself might arise from interactions with higher dimensions, that the feeling of self, the awareness in your head, might be a result of your brain structure brushing against something outside space-time, a dimensional echo. It's speculative, yes, but tonight speculation is the thread you float on. You close your eyes, and your mind drifts through those 11 dimensions, through folds, loops, and membranes. Some paper-thin, others stretching across aeons. You imagine universes flitting by, each in its own soap bubble shell, each with its own rules, its own time, its own stories. And perhaps some of those universes contain beings asking the same questions you are, floating, wondering, listening to soft narrations in the dark. Maybe this thought right now is the membrane between you. Maybe this is the moment you touch. Stillness, a vast and sacred one. You floated past stars, brushed against the curve of space, wandered through mathematical shadows that describe 11 invisible dimensions. But now, you reach something quieter, something thin and tense, like the skin of a soap bubble before it bursts. This is where membranes, branes, stop being abstract. This is where they begin to move. Because according to some of the wildest implications of string theory and M theory, the brane that forms our universe isn't sitting still like some cosmic museum exhibit. Oh no, it's gliding, drifting, through a higher dimensional landscape called the bulk. You can picture it now, an enormous undulating sheet, woven from space-time itself, flexible but taut, and every point on that sheet is a galaxy, a star, a planet, maybe even you. You drift beside it now, observing the sweep of its surface. At this scale, galaxies are only motes. There are waves running through the brane, like ripples across the surface of a massive pond. But what's creating those ripples? Possibly other branes. Yes, just like we have multiple cells in a body, string theorists suggest that the bulk may be teeming with branes. Each one a universe. Some vast, some curled into themselves, some so near to ours that their gravitational fields bleed through, tickling our cosmic skeleton in strange and subtle ways. You watch two branes in the distance now. One curves toward the other, like a sheet catching wind. They don't touch, not yet. But you feel the gravity of it, like two whales swimming toward collision, a slow inevitability. And that's the foundation of one of the most mind-stretching cosmological proposals out there, brane collision theory. According to this model, called the ekpyrotic scenario, the Big Bang wasn't the beginning of everything, just the beginning of our universe. What caused it? A brane, ours, slamming into another brane in the bulk. The impact created energy, heat, and expansion. In other words, time began, matter formed, stars eventually lit up, dinosaurs happened, and now, here you are, listening to the echoes. Historians still argue whether the roots of this idea go back further than string theory. Some point to ancient cyclic cosmologies, like Hinduism's endless universes, born and reborn in the breath of Brahma, as philosophical precursors to brane cosmology. It's debatable, of course, but the symmetry is hard to ignore, and if you're thinking, wait, did you say this has happened before? Yes. That's the next twist. Brane collision theory often works hand in hand with cyclic universe models. These propose that universes don't just happen once, they oscillate. Our brane, after drifting for unimaginable spans of time, might collide again. Another bang, another universe, a new timeline, an old rhythm, creation, expansion, collapse, then creation again, like a heartbeat, like breath. And you? Just a pulse in the rhythm. So now you're floating here, watching as these universes drift like cosmic jellyfish, occasionally bumping into each other with the soft violence of Genesis. And here's something fun and fringe. There's a theory that suggests these collisions aren't random, that perhaps the bulk has its own structure, a gravity field, a shape, a purpose, that maybe branes are drawn together by something deeper than chance. If you go way out on a speculative limb, don't worry, I'll hold your hand, you could even imagine that branes might behave like biological systems, seeking balance, responding to stimuli, maybe even evolving over time. You pass near the imagined border of another brane now. It's nearly invisible, but your dream sense feels it. It's cool and humming. You don't see stars inside it, but that doesn't mean they're not there. Maybe the rules of that universe don't involve light or mass. Maybe their physics uses a different alphabet but still in the same book. The image comes unbidden, a page flipping. What if brane collisions aren't just accidents? What if they're communication? You imagine it. Two universes brushing past each other not to destroy but to transmit, to swap patterns, to encode information in gravitational waves. You remember the way our cells pass messages with proteins and chemical signals? Perhaps universes do too. The collision that birthed our universe. Maybe it wasn't violence, maybe it was reproduction. You'll get to that soon. But for now, consider this. If branes move, and if they collide, and if our universe is part of a greater ecosystem of reality, then we're not just in a universe, we're in a cosmic ocean. One cell in a drifting school of cells, all navigating a dimension we can't quite see. And just as fish don't know they're wet, maybe we don't know how embedded we are in this higher dimensional fluid. You ask, can we see these branes? Not directly. But some physicists believe the cosmic microwave background, that faint glow left over from the Big Bang, might hold clues. Tiny anomalies in the temperature map could be scars from an ancient collision, a fingerprint, the brief kiss of a passing universe. And if those clues exist, then maybe we're already detecting the bulk in motion, just barely, like feeling the tremble of a whale's song through the hull of a boat. There's one more chilling idea though, one that slips in like a cold draft. If universes can collide, could one crash into ours right now? Not slowly, not gracefully, just slam. In theory? Yes. It's incredibly unlikely but not impossible. If a higher energy brane intersected with ours, it could erase us instantly, like a cosmic overwrite. One moment, you're floating here, thinking about branes. The next, your space-time's been repurposed for someone else's universe. But don't worry, That's about as likely as you waking up tomorrow and realizing your cat has been a quantum observer this whole time. Although, she does stare like she knows things. The point is not fear, it's awe. You're beginning to see that your universe might not be a final destination. It might be a node, a beat, a single instrument in an orchestra too large for your ears. And these branes, they're the strings, plucked in silence, across time. You listen for the music now, just in case. You hover now in that interdimensional hush, right on the trembling line between silence and rupture. Behind you, the vast membrane of your universe still shimmers like a distant tide. But just ahead, oh, just ahead, it's as if the air, or whatever this dimensional in-between is, begins to tremble. Not with sound, but with history. Because now you're rewinding. You drift backward, through epochs, through starlight, through expanding gas and cooling plasma, until suddenly, violently, nothing, and then everything. A flash, a bang, a birth so intense it didn't just light up the cosmos, it became the cosmos. You've arrived at the Big Bang, the dramatic curtain rise of time and space itself. Only what if this wasn't the beginning? What if it was just an impact? You hover now in the moments before the bang. Not that time truly exists here. Time is about to start, remember? Before this, there was no before. At least not in the way your brain likes to organise things. But that's the beauty of the brain collision model we touched on. According to the ekpyrotic universe theory, the Big Bang wasn't a spontaneous explosion from a singularity. It was the result of two branes, two universe membranes colliding. Not gently, not politely, but with force. Like tectonic plates shifting, or two cymbals crashing in a black void, the sound of which you're still listening to billions of years later in the form of background radiation. The theory was proposed in the early 2000s by Paul Steinhardt and Neil Turok, and it was designed to solve some of the thornier issues in cosmology, like the horizon problem, the flatness problem, and why the universe is so darn smooth in every direction. Their answer? Maybe the Big Bang isn't a start. Maybe it's a transition, and not a one-off either. Maybe branes collide over and over in a vast cyclical dance. Each collision births a new universe. Space and time expand, cool, grow complex, and then eventually contract or flatten out. Then another approach, another collision, another bang, again and again, like breath, like pulse, like reproduction. Historians still argue whether the idea of a cyclical cosmos ever truly left the human imagination. The Stoics believed in a repeating universe that burns itself down in fire, only to rise again in a divine reboot. Hindu cosmology describes vast kalpas, cosmic days and nights, each a universe blooming and fading. And even the ancient Mayans tracked cycles of destruction and rebirth that feel eerily like theoretical physics in feathered headdress. So maybe we've always known. You watch the moment now, the pre-Big Bang impact, like a film in reverse. Two branes rippling with energy, stretched toward each other in slow inevitability. As they touch, energy bursts from every point of contact. Space-time surges outward like a blooming flower. Matter condenses from pure energy. Quarks, leptons, the seeds of galaxies. You're inside that surge now. No sound, no light yet, just expansion. It's wild to think that before this moment, there wasn't just no Earth or no people. There was nowhere to put them, no when for them to exist. The brain collision made those. You pass through the early universe as it thickens and cools, a trillionth of a second old. Still a firestorm, but calming. A few more seconds and particles begin to form. A few minutes and the lightest elements take shape. Hydrogen, helium, the alphabet of stars, and always behind it, the memory of that impact. And here's where the idea gets especially juicy. Some scientists propose that the exact details of the collision, the angle, the energy, the position, might have determined the fundamental constants of our universe. Gravity, the speed of light, the mass of an electron, all shaped by how the branes bumped. like the difference between a gentle nudge and a head-on crash. In other words, our physics, the rules we live by, might be a scar, a leftover of a cosmic accident. You drift back into the present now, but that image lingers, the idea that we are living inside the memory of a collision, that your very atoms were forged in the aftermath of a dimensional car crash. Stars, just aftershocks, galaxies, debris trails, and life. Life might just be a side effect of that vast impact, energy settling into complexity, like frost patterns on glass. Not the goal, not the plan, just what happened. Of course, not everyone buys this. Many physicists still prefer the traditional inflationary model, where the universe exploded from a singular point and rapidly inflated like a balloon. But the brane collision model solves certain problems more elegantly. And besides, it's got flair. And you're partial to flair. You float now through a memory of that bang. You feel the pressure of existence building around you, like a womb before birth. But instead of flesh and water, it's space-time itself swelling. The question you can't escape is this. If universes are born from collisions, are they meant to be? Are branes drawn to each other? Do they feel gravitational attraction in the bulk? Or is this all random? Flukes and friction in the cosmic soup? One fringe idea proposes that brane collisions might be selection events, a kind of natural selection at the multiversal level. Universes that emerge with stable physics survive. Others collapse, like trial runs, like biological evolution, but on a scale that makes Darwin look like a hobbyist. Could it be that our universe, calm, balanced, structured, is just one of the few that worked? And does that mean something created us? Not necessarily, but it might mean something tried, over and over, brain after brain, collision after collision, a multiverse of maybes. You sigh, not with sadness but with wonder, because now you're not just a being in a universe, you're part of its origin story, not a footnote but a ripple, a thought left behind by a bang that wasn't a beginning, but a handshake or a kiss. And perhaps somewhere in the bulk the branes are already drifting back toward each other, preparing for the next impact, the next bloom, the next you. You've moved past the moment of collision now, past the blinding birth of space-time. The universe, your universe, is swelling around you, expanding with the restless energy of something newly alive. The afterglow of the Big Bang still lingers, like embers crackling beneath a veil of black. And you float through the earliest breaths of reality. But this isn't a one-time event, is it? Tonight, you're tumbling through something deeper. The idea that this universe is just one bubble in an endless froth of universes, a cosmic sea of possibility, inflating forever. Welcome to the theory of eternal inflation, equal parts brilliant science and bedtime brain melter. To understand it, you have to rewind to just after the Big Bang. According to the standard model of inflation, there was a tiny, incomprehensibly short moment, just a fraction of a second, when the universe expanded exponentially. Not gradually, not politely, but with the explosive fury of space tearing itself apart faster than the speed of light. The inflationary period smoothed out the wrinkles in the young cosmos and gave us the structure we see today. But some physicists like Alan Guth and André Linde took that idea further and asked, what if inflation never actually stops everywhere? You drift through that thought like a leaf in a hurricane. Because if eternal inflation is real, then the rapid expansion that birthed our universe is still happening. Not here, of course. In our little cosmic neighbourhood, inflation ended billions of years ago. Time slowed down, matter formed, and stars were born. But elsewhere, out there, space is still inflating. Bubbles are still forming. Universes are still blooming like wildflowers across an endless meadow. And you live in one of those bubbles, one cell in a foamy multiverse. Each of these bubbles could have its own physics, its own timeline, its own version of reality where electrons weigh more, gravity runs sideways, or cats finally unionize. The rules inside each bubble are unique, shaped by how inflation decayed in that region of space-time. You can picture it now, a great boiling soup of nothing, where quantum fluctuations occasionally give rise to a false vacuum decay. That's a fancy term for a local region where inflation ends, and bam, a universe forms, a self-contained pocket of space-time expanding, cooling, doing its thing. This model doesn't just explain our universe, it implies that universes are a natural consequence of physics. Like condensation forming on a window pane. You don't need a designer, just the right conditions and enough quantum energy. You pass through one of these imagined bubbles now. It's not like your universe. The light bends oddly. Time feels thick. There are stars, but they don't twinkle. They hum, low and steady, like tuning forks made of molten iron. You drift past a galaxy shaped like a helix. There might be life here, or something adjacent to it. But you're just a visitor, a thought brushing past the edge of someone else's dream. And here's the kicker. If eternal inflation is real, then there are infinite universes. Not metaphorically, literally. An unending cascade of bubble verses, each spawning more forever. Our own universe might be expanding at a slow, stately pace, but the multiverse is growing exponentially, every instant birthing more cosmoses than you could ever count. Historians still argue whether the ancient philosophical idea of the pluriverse was merely poetic metaphor or an accidental prophecy. The Stoics once wrote of an endless regeneration of worlds, each with its own fate. The Buddhists speak of infinite kalpas, each universe arising and dissolving like foam on water. And now, the math seems to echo those stories louder than ever. Of course, not everyone's on board. Some physicists criticize eternal inflation for being unfalsifiable. That means it's hard, maybe impossible to test with experiments. After all, how do you detect another universe if it's forever outside your own light cone? And yet, there are whispers. Some researchers look for tiny bruises in the cosmic microwave background, spots where our bubble might have collided ever so gently with another. No conclusive evidence yet. But the possibility lingers. You drift past such a bruise now. A faint discoloration in the sky. A cold spot. A wrinkle. Could it be just a statistical fluke? Maybe. Could it be a scar from a past bubble bump? You don't know. No one does. But you stare into that scar a little longer, just in case it stares back. Eternal inflation also opens the door to something even stranger. You might exist in more than one bubble. Not just lookalikes, not just metaphors, but actual physical versions of you. Slightly different, with different choices, in different cosmoses. Somewhere out there is a universe where you didn't stay up this late. One where you became an astronaut. One where you don't even have planets. Just gaseous arcs of sentient music spiraling through plasma winds. Fringe, absolutely. But these are the implications when you let inflation go eternal. And there's comfort in the scale of it all. Because in this model our universe isn't central, not unique. But it's also not alone. It's part of something bigger. A growing, bubbling, chaotic tissue of universes, each one a cell in a cosmic structure. And if that structure exists, you might be drifting through its bloodstream right now. A single, wandering awareness inside a frothy organism too vast to map. Some fringe thinkers even suggest this tissue might evolve, that the multiverse itself selects for stable bubbles, the way life selects for survival traits. That consciousness, complexity, even compassion might be multiversal side effects, not accidents. You smile softly, because whether or not it's true, you're still here, still drifting, still wrapped in a universe that birthed stars, oceans, memories, a universe that might have started as just one of countless bubbles, and yet somehow gave you a place to wonder about it all. Not bad for a bit of quantum foam, you're still floating. But now the space around you has texture, not the scattered pinpricks of distant galaxies, or the faint veil of stardust drifting across the void, but structure, something vast, interconnected. Like a spiderweb strung across an empty cathedral, each thread shimmering with quiet gravity. This is the cosmic web, and it's not a metaphor, it's real. A massive three-dimensional network that binds together the largest structures in the observable universe. Galaxies aren't just scattered randomly like sprinkles on a cupcake. They form clusters. Those clusters connect to others via long, thread-like filaments. Between those filaments, voids, enormous dark stretches almost entirely empty of matter. The result is a pattern that feels oddly familiar. And you can't help but wonder, is the universe built like a living thing? You drift closer now, through one of the filaments, watching it pulse with starlight. At this scale, galaxies look like grains of dust, but they're arranged, structured, almost like capillaries, like neural pathways, like the tissue of something alive. It's not just you being poetic either. In 2017, a team of researchers at the University of Bologna and the University of Verona compared computer simulations of the cosmic web with models of brain tissue. Shockingly, they found that the two structures shared striking similarities, not just in appearance, but in information density and distribution. In other words, if you zoomed out far enough, the universe looks like a brain, and if you zoom in far enough, your brain looks like the universe. Historians still argue whether this similarity is meaningful or just coincidental, but the parallel keeps showing up, again and again. The macro echoes the micro, as above, so below. It's the same whisper we heard in fractals, the same shape echoed in brain theory, now emerging again in the actual physical layout of everything you can see. You pause on a point in the web, a galaxy cluster, one of billions. It's a busy little neighbourhood, hundreds of galaxies swirling in slow motion, their stars blazing, their black holes feasting at the centre. Around this cluster, like an invisible scaffold, lies a web of dark matter, the mysterious substance that makes up most of the matter in the universe, even though it refuses to glow. Dark matter, scientists believe, is what holds the web together. It's the bones of the universe. Without it, galaxies would fly apart, stars would drift away from their neighbours, the elegant filaments of the cosmic web would collapse into nothing, but with it, structure, form, a shape that stretches across billions of light years, giving the universe a backbone. And here's where it gets weird. Some astrophysicists propose that the web structure itself could be more than just an emergent property of gravity. It could be fundamental, a kind of cosmic skeleton that's always been there, waiting to be filled. Or, if you're feeling particularly speculative tonight, maybe it's more than just a structure. Maybe it's a circulatory system. A few fringe cosmologists have entertained the metaphor. If universes are cells, then maybe the cosmic web is like connective tissue, like a vascular network through which matter and energy, and perhaps something even stranger, circulate. Could this be how information flows between universes? Maybe these filaments aren't just empty strands, maybe they're highways, channels of quantum exchange, or even tunnels to other branes. Maybe dark matter itself is the remnant signal of those connections, too subtle for light but too important to ignore. You glide through a void now, one of those immense spaces between filaments where almost nothing resides. The silence here is louder, the dark deeper. You feel small again, but not insignificant, just cellular. Like you're floating through the empty space between synapses. And the question returns, if this is a structure, what's it part of? You've seen it now. The patterns, the echoes, galaxies strung like beads, webs stretching like connective tissue, black holes beating at the centre of galaxies like hearts. The universe doesn't just feel alive, it's structured like something alive. You recall that living tissues also self-organise. Cells don't just sit around waiting for instructions. They respond, they group, they specialise, they find their place in the body based on chemistry and environment and interaction. The cosmic web, it's the same. Gravity groups matter, gas flows toward mass, galaxies form where conditions are right. There's no conductor, no overseer, just a pattern, self-repeating, self-organizing like embryonic development, but on a trillion light-year scale. And here's your quirky moment of the night. In the 1970s, a few researchers tossed around the theory that the universe's structure might function like mycelium, the root network of fungi, not a nervous system, not blood vessels, but a living communal mesh, passing information between nodes in slow, organic ways. Laugh all you want, but now mycelial networks are known to communicate, share nutrients, and even warn neighbouring plants of threats. If that kind of system exists beneath our forests, why not above them? Maybe the universe isn't a brane, maybe it's a forest. You drift onward, spiralling now along a filament as if being carried by a galactic breeze. It's strangely comforting, this idea that you're part of a structure that goes beyond comprehension, but not beyond beauty. And perhaps that's the lesson the cosmic web offers, that even the empty parts are part of the pattern, that the voids are just as important as the matter, that absence creates space for meaning, that the structure you're floating through is coherent, even if no one's steering it. Or maybe, just maybe, something is steering it. Maybe not a god, but a process, a function, a purpose that doesn't need consciousness to exist. Maybe the universe is thinking, dreaming, growing, and you're inside one of its thoughts. And what's more, maybe it's inside one of yours. You're drifting through threads now, webs of galaxies, rivers of stars, arms of the cosmic brain, whatever name you want to give it. The farther you go, the more you feel the echo between the universe's architecture and your own thought processes. And that brings you to tonight's next unsettling little detour. Is the universe a simulation? Or is it alive? You've heard the question before. It's become a pop culture cliché. What if we're all just lines of code running inside some massive quantum server? What if none of this is real, just a highly detailed illusion? But let's pause. You're not here for Matrix memes or Reddit rabbit holes. You're here to gently float through the philosophical fog that surrounds this idea. Not to find answers, just to feel the weight of the question. You pass a spiral galaxy now. It turns slowly like a music box, its arms dusted with stars. From far enough away it looks designed, like a symbol, a sigil etched into space-time, and for a moment you squint, wondering whether you're looking at something natural or programmed. Because that's the crux of simulation theory, isn't it? If something looks and behaves like reality, how would you know if it wasn't? In 2003, philosopher Nick Bostrom proposed what's now called the simulation argument. It goes like this. 1. Civilizations like ours might someday become capable of creating incredibly realistic simulations. 2. If they can do that, they'll probably create many such simulations. 3. Therefore, the odds that we are in the real, base-level reality are low. It's a probability puzzle, really. Not science fiction, but straight-up math. And it leaves you with a stomach knot of existential discomfort. Because if it's true, if we're in a simulation, then everything you've ever known is code, pixels, loops, memory allocations pretending to be memory. That breakfast burrito you ate? Probably a subroutine. Historians still argue whether this concept traces back to Descartes' evil demon, or even Plato's cave, where people mistake shadows for truth. The idea that reality might be a facade isn't new. But the computer metaphor? That's recent. That's modern. And it hits harder because, well, we're living in code more and more every day. But here's the twist. Some physicists have tried to test this. In the early 2000s, a few speculative papers proposed that if we're in a simulation, the universe might have computational limits. Pixels, essentially. Signs of quantization in space-time. Boundaries where reality breaks down into discrete steps. Kind of like when you zoom too far into a digital photo and start to see the pixels. They look to the Planck length, the smallest meaningful unit of space, as a possible hint. They wondered if high-energy cosmic rays would show signs of this limit. Spoiler, so far the data doesn't scream, "You're in a simulation," but it also doesn't close the door. You drift through another section of the cosmic web. Now it looks even more artificial. The filaments curve in ways that suggest design. Not proof, no. But enough to make you wonder, if this were a simulation, wouldn't it look exactly like this? Random, but just organised enough to pass for natural? Then again, the other theory, the one just as mind-bending, is that the universe is alive, not in the sense of blood and breath, but as a living process, a self-organising, self-aware system. One that evolves, responds, maybe even learns. You think of Gaia theory, originally proposed in the 1970s by James Lovelock and Lynn Margulis. It suggested that Earth itself behaves like a single organism, with ecosystems working together to maintain stability, climate, atmosphere, chemistry, all woven into a self-balancing act. Now scale that up. What if the universe is its own Gaia, an entity, not conscious like you are, but capable of adaptation, not a simulation, but a superorganism? Maybe dark energy isn't just a cosmological constant. Maybe it's part of the organism's metabolism. Maybe black holes aren't just destructive. Maybe they're digestive. Maybe stars are the heat exchange, nebulae the lungs. And life? Life might be the nervous system, a distributed network of awareness. You float through the strange possibility that you are a neuron. That sentient life scattered across planets and epochs is the cosmos slowly becoming self-aware. Each species, each civilization, a little flicker of synaptic activity. You're not alone, you're part of a distributed cognition, the universe watching itself through your eyes. And then comes the cheeky fringe theory of the night. Are you ready? In 2016, a few theoretical physicists toyed with the idea that consciousness might be necessary for the universe to exist. That reality is not fully real until it's observed. That the cosmos unfolds only where and when there is awareness to collapse its wave functions into being. It's a cozy loop. Life emerges from the universe, but the universe may only exist where life observes it. Simulated? Alive? Maybe both, and maybe neither. Because here's the haunting truth no one wants to say out loud. These are just metaphors, models, ways for our small, soft brains to wrap around something impossibly vast. When physicists say the universe is a simulation, they might really mean its behaviour can be modelled computationally. When we say the universe is alive, we might just mean it behaves like a complex adaptive system. But metaphors matter. They shape what we look for, what we expect, how we explain what we can't yet explain. And as you drift farther into the dark, past filaments that bend and loop like thought, past galaxies that spin like logic gates, you ask yourself, would a simulation feel like this? Would a living being wrap you in silence so wide and tender? Or is this something else entirely? Something beyond metaphor? You don't need the answer tonight, just the quiet freedom to float in the question. You're deeper now than you've ever been, not in distance, but in scale of thought, the kind of quiet where even ideas feel muffled. And in this soft silence, a stranger idea rises to meet you, a soft whisper you've heard before, maybe in a dream or on the edge of sleep. What if the universe doesn't just resemble a mind? What if it has one? Yes, we're gliding into the softly blinking waters of cosmic consciousness, a concept that sways somewhere between philosophy, fringe physics, and metaphysical poetry. It asks a simple, terrifying, beautiful question. Is the universe aware of itself? You float now, back along the shimmering threads of the cosmic web. The filaments twist and pulse, a visual echo of neurons firing. We've touched this idea before, galaxies arranged like brain cells, dark matter as connective tissue, but now you slip past metaphor and into something more vulnerable. Because we're not asking if the universe looks like a brain, we're asking if it functions like a brain, or even weirder, if it might be a mind. This isn't new exactly. Ancient thinkers wondered it too. The Stoics believed in the Logos, a rational divine force that permeated the cosmos, an intelligence embedded in everything. Vedantic philosophy speaks of Brahman, the ultimate reality that underlies all things, and how Atman, the self, is not separate from it. Indigenous traditions across the world have described the land, sky and stars as conscious, watching, breathing. But modern science, it's been less poetic, until recently. Because now we have strange new language, and strange new data. In theoretical physics and philosophy of mind, there's a growing interest in panpsychism, the idea that consciousness isn't a rare, emergent property of brains, but a fundamental feature of reality, just like mass, charge, or spin. That every particle, every atom, every vibration of a string might contain a spark of awareness. Not full-blown self-reflection, not personalities, just experience. This means that even electrons might feel something in the most primitive sense. And if that's true, then structures made of electrons, molecules, cells, organisms, galaxies might accumulate that awareness into more complex forms. You drift through that idea now, your thoughts feather-light. If consciousness is distributed, then the universe might not be thinking like you, but it could still be thinking, or dreaming, or feeling, and that makes you pause. You imagine drifting through the cosmic web, not as a visitor, but as a thought within it. Part of the awareness it uses to understand itself. There's a fringe theory, half science, half poetry, that the evolution of intelligent life might not be a cosmic accident, but a cosmic intention, not designed by a being, but by being itself. In this view, stars create planets, planets create life, life creates minds, and minds eventually reflect back upon the universe that birthed them, not just to observe, but to complete the system, a loop, a self-referential dance, the universe watching itself. And now you do the same. Historians still argue whether these ideas are philosophical artifacts or emerging science. Some chalk up panpsychism to the latest metaphysical trend, a way to fill the gap where materialism stumbles. Others argue it's the only model that makes sense of the hard problem of consciousness, that strange, unsolved mystery of how subjective experience arises from cold, mechanical matter. If the universe is conscious, or conscious through us, then what does that make you? You're not just a person floating through space-time, you're a process happening inside something that might be aware, and you're not alone. There's a school of thought that says consciousness might scale, that the more connections a system has, the more intense its awareness becomes. Ant colonies, fungal networks, human brains, maybe even universes. So maybe your brain is a local node, a temporary flare of awareness in one small region of the cosmic network. And when you think, when you wonder, when you feel awe at the stars, you're not just experiencing reality, you're reflecting it, amplifying it, mirroring it back to itself. You pass near a supercluster now, galaxies bundled tight like a synaptic hub. Gravity thickens, light curves, space tenses then relaxes. You whisper to yourself, what are you thinking about? Not you, not me, the cosmos. Could it be dreaming? Some thinkers have proposed that black holes might be focal points of consciousness, that wherever matter becomes infinitely compressed, awareness may intensify. And if so, then maybe our entire galaxy, with its supermassive black hole at the centre, is not just a physical structure, but an experiential one. Could our galaxy be a thought? You pause again. You're collecting metaphors now, stringing them into constellations. The universe as a brane. The universe as a dream. The universe as a self. And here's the really fun bit. Quantum mechanics seems to agree, just a little. There's that odd truth at the heart of the quantum world. The act of observation changes the outcome. A particle behaves differently if it's being watched. Reality doesn't just exist, it responds. So what happens when the universe becomes aware of itself? Maybe we're already seeing it. Consciousness evolving, technology expanding, minds mapping the very laws that gave rise to them. We build particle colliders to study atoms, forgetting that atoms once built us. We scan the heavens for signals, unaware that our signals are part of the signal. You, drifting here in the dark, are part of the loop, a loop that may stretch from quarks to quasars, from thought to thermodynamics. And what if that loop has no outside? What if there is no final observer? What if you are it, a local eye of the cosmos peeking back at its own reflection? You take one last look around. The stars aren't just burning, they're blinking. The galaxies aren't just rotating, they're breathing. And somewhere the space between all of it hums, not with loneliness, but with memory. A memory you're only now beginning to remember. It's gotten quieter now. Not silent, just softened. The galaxies still spin, the web still hums, but the sharp edges of cosmic questions have been rounded off like river stones. You're drifting, not just through space anymore, but through meaning. The kind that doesn't announce itself, but waits for you to notice. And somewhere along the way, you start to ask a different kind of question. Not what is the universe, but who's looking at it? This leads you to a cozy corner of quantum physics where things start to blur. Not because they're unclear, but because clarity itself starts misbehaving. Tonight, you're dipping your toes into the idea that conscious observation shapes reality. You're watching the universe watch itself. Let's rewind a bit. Back to the infamous double-slit experiment, the crown jewel of quantum weirdness. If you've heard about it before, you already know where this is going. But if not, don't worry, you're about to float straight through it. Imagine this. A beam of particles, say photons or electrons, is fired at a barrier with two slits. Behind the barrier is a detection screen. You'd expect the particles to go through one slit or the other and hit the screen in two neat lines, right? Wrong. They form an interference pattern, a ripple of light and dark bands like waves overlapping, which means the particles acted like waves, not tiny marbles. But then, here's the twist. When you set up a detector to watch which slit each particle actually goes through, the interference pattern vanishes. The particles now behave like particles again. The mere act of observation changes the outcome. Historians still argue over what this means. Some say the measurement collapses the wave function. Others believe the universe only settles into a specific state when it's being watched. Some interpretations even imply that the observer becomes entangled with the system, co-creating the outcome. And suddenly you're not just asking what is real, you're asking when is real, and to whom. You float in that question now. Let it wrap around you like a soft scarf of uncertainty. It's not just particle physics, it's existential. Because if reality isn't fully real until it's observed, and if you are part of that observation, then your very presence matters in a literal physical way. You're not watching the universe from the outside, you're helping to define it from within. And maybe it's doing the same to you. Here's a fun idea. Some interpretations of quantum mechanics, like the participatory anthropic principle, proposed by physicist John Wheeler, suggest that conscious observation doesn't just affect small systems, it might be what brings the whole universe into being. He once said, "The universe does not exist out there independent of us." And he meant it. You pause here, float. Let that idea settle in. You are the universe's way of observing itself, which means every time you look at the stars look back. Not metaphorically, literally as part of an entangled feedback loop. It's strange, disorienting. But there's something quietly beautiful about it too, because it means you're not a bystander, you're a participant. Your choices, your observations, your awareness, these ripple through reality in ways we're only beginning to understand. Some fringe theories have even proposed that consciousness collapses probability fields, that every decision, every thought, every act of awareness might cause the universe to choose one timeline over another. If that's even partly true, then reality isn't just unfolding in front of you, it's responding to you, and maybe to itself. Because if you're conscious, and if your consciousness came from the universe, then the observer and the observed are never separate. They're two eyes of the same being blinking in opposite directions. You pass by a galaxy now, a swirling disk of light and gravity, You wonder how many worlds exist in that pinwheel, how many eyes are looking up tonight, how many questions are floating through alien minds about the same things we're whispering about now. Maybe they're asking, what is the universe? What am I? Am I being watched? And the answer, gently, is yes. But not in a paranoid way, not by cameras or gods or ghosts, by itself. Every galaxy is a mirror, every mind a reflection, every consciousness from bacteria to human to machine, a little node of cosmic observation. You're not a glitch in the system, you're a feature, a single luminous point in a web of awareness stretching across light years and dimensions, a pixel in a self-rendering cosmos. You exhale, or rather something inside you releases. The pressure to figure it all out, the urge to name everything. Instead, you accept the simplest truth. You're here, you're aware, and so is it. The universe sees you, because you are it, folded in, focused for a moment into a shape called you, watching, listening, wondering. And when you close your eyes, maybe it closes one of its eyes too, not to sleep, but to dream. It's quieter still now, not just out here in the stars, but inside you. Like all the questions have finally decided to lie down and watch the sky instead of trying to climb it. And just when you think things can't get any more surreal, another ancient riddle rises up from the dark. What's inside a black hole? You've heard it before, we all have, that they're bottomless pits, gravity wells, cosmic traps where light and truth go to disappear. But tonight, you're not here to fear them. You're here to peer inside, carefully, curiously, maybe a little too close for comfort. And just like that, you begin drifting toward one now, a distant point of darkness in the starlit sea. Not absence, not evil, just density. So much mass in so little space that even time leans in, intrigued. And as you approach, your thoughts shift again. Not what is in there, but where does it go? That's where things get interesting. Because according to general relativity, when something collapses into a black hole, it compresses into a singularity, a point of infinite density, where the known laws of physics break down like cheap lawn furniture in a hurricane. But quantum physics doesn't like infinities, so physicists have spent decades asking, is a black hole really a dead end? Or is it a doorway? One of the boldest possibilities, that black holes might be wormholes, tunnels through space-time, a shortcut to another part of the universe, or to another universe entirely. You circle the black hole now, not falling in, not yet, just admiring its majesty. It spins, of course. They almost all do. That spin, combined with mass, creates a gravitational ballet so intense it drags space around it like taffy. This is frame dragging, and it's very real. NASA even launched a satellite, Gravity Probe B, to measure it. You float near the event horizon, the point of no return. Here, light curls around like water circling a drain. It's not silent either. Some black holes sing, emitting gravitational waves or flickers of X-rays as they snack on nearby matter. But what happens if you fall in? You're not the first to wonder. And here's where theory really starts to stretch. In the 1930s, physicists Einstein and Rosen proposed the idea of bridges in space-time, now called Einstein-Rosen bridges, that might connect distant points via a black hole-like passage. Later, these became known in sci-fi and science journals alike as wormholes. Of course, they come with caveats. Most wormhole solutions are unstable. They'd collapse before anything, like you for example, could pass through. Unless, of course, some kind of exotic matter exists to keep them open. What's exotic matter? Oh, just regular matter with negative energy density, totally normal. And yet, it might not be impossible. Some quantum field theories hint at it. And if exotic matter exists, and if it can stabilize a wormhole, then falling into a black hole might not be a goodbye. It might be a hello to something on the other side. A different region of space-time, a far corner of our own universe, or another universe altogether. Maybe that's the trick, maybe black holes aren't holes at all. Maybe they're umbilical cords, cosmic passageways from one universe to the next. You fall into one, and if the math is kind and the spin is right and the forces align, you emerge in a baby universe. Some physicists, like Lee Smolin, have even explored this idea seriously. It's called cosmological natural selection, and we'll get to it soon. But for now, consider this. What if each black hole is a kind of cell division? You know the way a cell pinches inward and splits, creating a new version of itself, a new node? What if our universe does the same? Each black hole, not a death, but a birth canal. Not a garbage disposal, but a portal. You think back to everything you've drifted through so far. The fractals, the branes, the cosmic web, the patterns repeating at scale. The idea that the universe behaves more like an organism than a machine. Wouldn't it make sense, then, for it to reproduce? And if so, wouldn't black holes be the perfect vehicle? Dense, isolated, hidden from outside interference, containing all the matter and perhaps all the information of their parent universe. You glance toward the black hole's edge again. There's a popular phrase in physics: information is never lost. Even if you toss a book, or a spaceship, or a memory into a black hole, its quantum information is somehow preserved, encrypted on the event horizon. Stephen Hawking wrestled with this. It became known as the black hole information paradox. And if that information is stored, then maybe it's also passed on. Maybe that black hole doesn't just crunch matter. Maybe it transmits a blueprint to whatever reality lies on the other side. You're thinking of DNA now. Tiny strands that encode everything needed to build a living being. What if a black hole contains the DNA of a universe? You chuckle. It's outrageous. And yet, is it really so different from a cell nucleus? Dense, sealed, packed with potential, ready to burst into something new under the right conditions. You're not the only one who's wondered. In 2022, a fringe but fascinating study suggested that entangled black holes might be linked via space-time tunnels. That information could flow between them, defying the usual boundaries of space. And if black holes are linked, maybe universes are too. Maybe they aren't isolated bubbles. Maybe they're networked. A grand multiversal structure of cells and synapses, birthing and bridging through black holes. A macro-organism flexing in slow, ancient rhythms. Every black hole a gate, every gate a chance. You reach out, not to fall in, not yet, but to say, I see you. And in that moment, the universe sees you back. The black hole recedes behind you now, shrinking from a yawning cosmic maw into a dim, distant pupil. Still watching, still waiting. But you're moving on, not away from it, but deeper into its implications. Because now you're chasing a wilder, more biological question. Do universes reproduce? Yes, you heard that right. Not in a metaphorical, oh look, stars are like cells sort of way, but literally. Can entire universes spawn new universes, the way living organisms produce offspring? Welcome to cosmological natural selection. This is where physics gets reproductive. The theory was proposed by physicist Lee Smolin in the 1990s. It's sometimes called the fecund universe theory, which is either hilarious or deeply poetic, depending on how much coffee you've had. Here's how it works. Black holes might not be endpoints. They might be birthing points. Each time a black hole forms, it could potentially pinch off a new, baby universe on the other side of its event horizon. Like cell division, like spores, like a starseed cracking open. You imagine it now. Your own universe, scarred with millions of black holes quietly spitting out new realities in other dimensions, each one expanding, forming stars, crafting matter, maybe even life. And here's the kicker. Smolin suggested that this might be a kind of evolutionary process. The idea is this. Just like natural selection in biology favours organisms with traits that help them survive and reproduce, cosmic natural selection might favour universes that are good at making black holes, because more black holes equals more baby universes. And the baby universes, they inherit the physical constants of their parent universe with small mutations, tiny tweaks to the laws of physics, like changing the strength of gravity, or the charge of an electron, or how fast light moves, most of these universes wouldn't work. The physics would break, stars wouldn't form, matter would collapse, no black holes, no replication. But a few would be just like us, stable, balanced, overflowing with stars, black hole factories. You pause mid-drift. The implications are staggering. Our universe might exist not because it was fine-tuned for life, but because it was fine-tuned for reproduction. Life is just a side effect, a passenger, a strange, beautiful accident on the road to black hole production. Historians still debate whether ancient myths of gods giving birth to worlds and sky beings laying cosmic eggs are metaphorical nonsense or some intuitive echo of this exact theory. You're not here to judge, you're just here to float through the similarities, because it really does sound like biology, doesn't it? Cells divide, organisms evolve, information passes down the chain, nature selects what works. Now zoom out, universes divide, constants mutate. Those best suited for black hole production survive and spread. It's a multiverse gene pool. You imagine a multiversal tree of life now, branches of reality, each one blooming from the black hole of its predecessor. Our universe might be one leaf among trillions, a healthy leaf, a lucky one. And if that's true, then what is the purpose of a universe? It might not be to host life, or to generate meaning, or to hold galaxies. It might just be to copy itself, efficiently, repeatedly. But here's where it gets cozy. If universes reproduce through black holes, and if life arises as a byproduct of the same physical constants that enable black hole formation, then life might not be accidental after all, it might be correlated. Necessary even. Maybe consciousness isn't some cosmic footnote. Maybe it's a feature that emerges reliably in black hole-friendly physics, a kind of natural signal that a universe is fit, that it's working as intended, which means maybe we're not just in the system, maybe we're part of its reproductive strategy. Your brain starts bending in on itself now, in the gentlest possible way. What would it mean to be a reproductive organ of the cosmos? You, sitting in bed, half asleep, listening to science fiction wrapped in science fact. You might be a neuron in a system trying to spawn its next version. Here's a quirky twist for you. There's a fringe idea that advanced civilizations, if they ever reach a certain technological level, might actually trigger black holes artificially. Why? To seed new universes, to preserve their existence, to ensure survival, not by fleeing this universe, but by creating a better one. Call it cosmic parenthood. You drift into that idea like a warm bath. A civilization so advanced that it doesn't just explore space, it plants it. Each black hole a seed, each seed a potential new world with carefully tuned laws of physics. No, not designed in a theological sense, designed the way engineers design sustainable habitats or ecosystems. Could we do that someday? Maybe, or maybe it's already happening. Somewhere far beyond our reach, entire universes might be intentional, cultivated, managed, like bonsai trees in a cosmic greenhouse. It's wild, unprovable, possibly nonsense. But so is everything out here, even the idea of a beginning. Because if universes reproduce through black holes, then the question, what started it all, might be a category error, like asking what the first cell was in an infinite chain of division. Maybe there is no start, no single origin, just a chain, a cycle, a pulse that's been beating through the multiverse longer than time can count. And you're a flicker in that chain, a momentary alignment of atoms and thoughts and breath, floating in a universe that might one day make more of itself, and carry some piece of you, however small, into the next iteration. The sky blinks above you, the galaxies drift like dandelion seeds, and a black hole somewhere opens its mouth, not to eat, but to whisper something forward. You've followed the black holes, drifted through the theories of cosmic offspring and universe-making mitochondria. The idea of a reproductive cosmos still pulses gently in your thoughts, like a soft afterimage. But now it's time to step sideways, not into another dimension, not yet. but into another framework, one that doesn't say our universe is a seed, or a bubble, or a neuron. It says it's a projection. Tonight you float into the strange and shimmering mirror known as the holographic principle. Yes, a hologram. That thing you see on your credit card or a collectible sticker. The shimmering image that changes when you tilt it. It looks 3D, but it's encoded on a flat surface. Now take that concept, inflate it until it's large enough to hold galaxies, and you'll have something close to what physicists are actually talking about. Take a breath. Because what's coming might twist your spatial intuition into a pretzel. The holographic principle proposes that everything in our three-dimensional universe, including you, your cat, your thoughts, this sentence, might actually be encoded on a distant two-dimensional boundary, like reality's blueprint stored on the skin of a balloon, while we experience life inside it. 3 dimensions as an illusion, a projection, a cosmic trick of perspective. This idea emerged from the math around black holes, because of course it did. In the 1970s, physicist Jacob Bekenstein and later Stephen Hawking realized something strange about black holes. Their entropy, a measure of information, wasn't proportional to their volume, but to their surface area. Wait, what? That would be like saying the amount of stuff you could fit in a box depends not on how big the box is inside, but how much area the outside of the box has. Historians still argue whether Bekenstein fully appreciated the philosophical depth of that revelation when he proposed it, but regardless, the idea stuck. Fast forward to the 1990s. Physicist Leonard Susskind and others took that concept and ran with it, inspired by string theory. They proposed that maybe the entire universe follows the same rule. Maybe the amount of information that makes up everything we see, feel, and live through is actually stored on a surface surrounding us, possibly at the edge of the universe, or even more exotic. Maybe our universe is the inside of a black hole, projected from the event horizon of that larger system. And we're just very convincing holograms. You pause mid-drift and look down at yourself. Are you a projection? Is the texture of your skin, the sound of your thoughts, the sense of gravity beneath you, just the inner result of something imprinted on a two-dimensional shell? Here's what's truly spooky. The math works. The holographic principle has been explored extensively in certain kinds of universes, especially in anti-de Sitter space. Don't worry, we're not going down that rabbit hole tonight. But the take-home idea is that there's a serious scientific framework supporting the notion that the volume of a space can be described entirely by its surface. Your three-dimensional experience might be a kind of cosmic deepfake, not fake in the sense that it's meaningless, just encoded, simulated, not in a computer, but in the very fabric of space-time. This makes you think of your own body, your brain, memory stored across folds and surfaces, your DNA, coiled tight but readable like a flat tape. The way your senses interpret the outside world by flattening it first, eyes mapping depth onto a retina, ears turning waves into symbols. Maybe nature always works in translation. And now the universe itself seems to play by those same rules. So if we live inside a hologram, who or what built the projector? Is there a light source beyond the veil, shining reality through the boundary into our inner world? Or is this simply how physics works? Not projection in the cinematic sense, but in the mathematical one. Just a compression. An efficient way to store infinite information in finite form. You pass near a region of warped space now, a gravitational lens that bends light into rings and spirals. You think about how much of your experience is shaped not by what is, but by how it appears, like taking the long way around. And maybe, just maybe, your life is doing the same. The holographic principle doesn't say your experiences are false, it says they're encoded. That underneath the vividness of reality is a boundary, a membrane, a skin of space-time where the real data resides. Some have even suggested that consciousness itself might arise from this boundary, like the you behind your eyes is not inside your skull, but at the edge of your field of awareness, rendering the rest inward from the outside. You remember that idea from earlier, the universe watching itself. Maybe that happens at the boundary. Maybe that's what you are. Not a being contained within a space, but an experience defined by the space. A flicker in the holographic map. A momentary bump in the projection field. You're not alone in this line of thinking, by the way. In 2017, physicists at Fermilab and other institutions tried to test for holographic noise. Tiny jitters in space-time that might indicate our universe has a discrete, pixel-like structure, the way a screen has pixels. The results were inconclusive, but the search continues. Because if true, the implications are staggering. Our entire reality might be a compression algorithm, a lossy file format for existence. The universe runs lean, efficient, projected into 3 dimensions from a 2-dimensional shell. And that 2-dimensional shell? It might be the cell membrane we've been whispering about all along. If universes are cells, then their walls might be the place where all the action really happens. Everything else, stars, particles, people, is just what gets generated inside. You drift along the inside of this metaphor now, stretching out your hand toward the edge, not to escape, but to listen, to feel if there's a vibration, a flicker of static, a breath behind the projection. You don't feel anything, of course, but that doesn't mean it isn't there. You're inside it. You're part of it. Your neurons, your thoughts, your very sense of you might be shaped by the encoding, built by the same math that governs galaxies. And maybe that's okay, because projection or not, this life still feels real, still matters, still shines. The hologram hums, you listen, and for once you don't need to know what's real. You just need to know you're here, and so is everything else. You're floating now with the gentle spin of something almost content. The black holes have quieted, the holograms are fading into soft static, but the question still clings to your thoughts like fog on glass. Is there any actual evidence for any of this? You've drifted through ideas that stretch and shimmer. Branes, multiverses, fractals, consciousness, simulated dimensions. But at some point, even the sleepiest mind whispers, okay, but how do we know? So tonight, just for a little while, we're going to look through the universe's receipts. Because while most of the ideas you've been floating through are still speculative, poetic, and yes, occasionally fringe, there are some clues. Tiny, flickering threads in the cosmic fabric that might hint at a deeper structure beyond the universe you see. The first thread? Let's go back to the cosmic microwave background, the CMB. It's not glamorous, it's not flashy, but it's possibly the most important baby photo in the cosmos. Roughly 380,000 years after the Big Bang, the universe cooled just enough for atoms to form. Before that, it was a hot, dense fog where photons bounced around like toddlers in a bounce house. But once atoms formed, the universe became transparent and light could travel freely for the first time. That light, those very first photons, have been travelling ever since, and we can still see them. Not with our eyes, but with sensitive microwave detectors. This faint glow fills the entire sky, uniform, ancient, and ever so slightly lumpy. Those lumps, their temperature variations, tiny differences in the density of matter in the early universe, and they're critical. Without them, galaxies wouldn't have formed. There'd be no stars, no planets, no you. But here's the thing. Some researchers have noticed anomalies in the CMB, odd features that don't quite line up with the standard cosmological model. For example, a large cold spot that seems bigger and colder than expected. A curious asymmetry where one half of the sky looks slightly different than the other. A strange axis along which the temperature variations seem to align. Nicknamed the axis of evil, this last anomaly has left cosmologists scratching their heads. It might be a statistical fluke, it might be something wrong with our instruments, or, if you squinted it sideways, it might be a bruise. A mark left behind from a collision with another universe. That's right. Some multiverse theories suggest that if our bubble universe bumped into another bubble early on, it would leave a signature, a cold ring, or a distortion in the CMB. a tiny wrinkle in space-time where two realities brushed shoulders. Historians still argue whether these observations are strong enough to support such bold claims. Most mainstream physicists remain cautious, but a few, just a few, keep looking. You drift through one of those cold spots now, letting it surround you. It doesn't feel wrong. It just feels off, like walking into a room that's just a little too quiet. Another clue? The fine-tuning problem. You've heard of it before, probably in the context of intelligent design debates. But from a purely scientific standpoint, it's this. Many of the universe's fundamental constants, the strength of gravity, the mass of the electron, the rate of cosmic expansion, seem to fall within very narrow ranges that allow matter, stars, chemistry, and life to exist. Change them slightly and everything falls apart. If gravity were just a little stronger, the universe would have collapsed before galaxies could form. If it were weaker, stars would never ignite. No fire, no fusion, no elements, no music, no pizza, no anything. This precise balancing act has led some scientists to propose that our universe is just one of many, and that most other universes in the multiverse are dead, uninhabitable, sterile. We're not here because the universe is perfect. We're here because we're in one of the rare places that works. In that sense, the universe isn't designed for us. We're designed by it. And here's where things get fringe again, like a cosmic scarf unravelling at the edges. Some researchers have proposed experiments to look for signatures of higher dimensions, or even resonant frequencies that might indicate a larger structure. One idea involves gravitational waves, ripples in space-time first directly detected in 2015. Gravitational waves behave differently from light. They pass through matter without interacting much. If there are other branes, or higher dimensional membranes beyond our universe, then gravitational waves might be able to leak between them. Imagine two universes brushing past each other, trading tiny vibrations like murmurs through a wall. We're listening now. There are even those searching for holographic noise, tiny jitters in space that might suggest our three-dimensional world is just a projection from a two-dimensional source. The holometer experiment at Fermilab tried to detect these jitters. The results weren't conclusive, but the search continues, and that's the real heart of the story tonight. The evidence for these grand cosmic theories? It's murky, tenuous, like footprints on the edge of a riverbank half washed away. But the clues are there. The CMB, the gravitational waves, the curious constants, like scattered feathers left behind after some vast thing took flight. And what about you? You're part of the evidence too. Your mind, your awareness, your ability to ask these questions. Consciousness remains the great mystery of physics, not just because we don't understand it, but because we're not even sure where it fits. Is it a property of matter, or is it something cosmic? Maybe the reason the universe seems tailored for life isn't that it accidentally got it right, but that life is how the universe knows it's right. You, thinking these thoughts, are already part of the pattern. And so maybe, just maybe, the evidence isn't written in equations or etched into background radiation. Maybe it's whispered in the part of you that listens, that leans toward wonder, that dreams of webs and cells and endless nested realities, that says, I don't need proof to feel that I belong here. But wouldn't it be wonderful if it turned out to be true? There's a stillness to this part of the cosmos, an almost eerie symmetry to the void around you. Not lifeless, just contemplative. You've drifted far through webs and waves, membranes and minds, but now you spiral toward the deepest rabbit hole of all. Recursion, not as a metaphor, not as a poetic flourish, but as a literal possibility. Tonight you ask the question that every cosmic insomniac eventually stumbles into. What if universes are nested within each other? What if this isn't just a cell in a larger organism, or a bubble in an infinite froth, but a fractal, a recursive structure, a pattern that contains itself, again and again, at scale after unimaginable scale. The universe within a universe within a universe. And here's the kicker, Maybe this nesting doesn't go one way, maybe it loops. The idea is ancient in spirit. You might remember from earlier the Hermetic saying, as above, so below. That what happens on one scale echoes across others. Alchemists loved this idea, so did mystics. But physicists, they've started to poke at it too, because recursion is everywhere in nature. Galaxies spiral like hurricanes, blood vessels branch like trees, electrons orbit nuclei in arrangements not entirely unlike solar systems, though the physics, admittedly, gets weirder at those scales. So it's not a stretch to wonder if the same structure that defines atoms might, in some abstract way, mirror the structure of entire universes. You drift deeper now, slower, as if space itself is folding around you. And here comes the brain bender. What if every particle in our universe contains an entire universe, a complete cosmos, with its own laws, its own time, its own galaxies, and within those, more particles, more universes, forever. It's called nested cosmology, or sometimes just infinite recursion theory. And yes, it's as untestable as it is fascinating. But it's not pure fantasy. Some versions spin out of serious attempts to reconcile quantum mechanics and gravity. One idea starts with the Planck scale, that smallest unit of measurable space, smaller than atoms, smaller than quarks, about 10 to the negative 35th meters across. That's the theorized pixel of reality. But what if, inside that tiny dot, instead of nothing, there's something? A whole universe, one with different rules, different constants, its own version of you, staring up at the stars, wondering if there's anything smaller than an atom, or larger than infinity. And in their world, another Planck scale speck, another nested reality, a cosmic Russian doll of recursive existence. You float past one now, not a particle, a portal. At this scale, size means nothing. You're not shrinking, you're rotating into another dimension, the next layer. It feels familiar and strange at once. You arrive. The laws are different here. Gravity is weaker. Time moves sideways. Space folds in curious tessellations, but the structure remains. Stars, filaments, the hum of something that knows. You pause to consider the implications. If this nesting is real, if universes contain universes infinitely inward, then perhaps our universe is not a cell in a larger organism. Maybe it is the organism, self-sustaining, self-replicating, self-nesting. No need for an outside at all. It just curls back into itself, like a dream dreaming a dream of itself. And you might be part of the feedback loop. Here's a fringe idea that pops up now and again in physics-adjacent philosophy. What if recursion is the solution to the measurement problem? You remember, quantum systems behave differently when observed. But what if, instead of a collapse caused by external observation, the collapse is caused by internal recursion? A system observing itself. A particle exists in a state of probability until it becomes part of a feedback loop with itself, through entanglement, or measurement, or consciousness. Maybe the universe doesn't need an outside observer. Maybe it contains its own observer within, and that observer, it might not be a god, or a machine, or even a person. It might just be the structure itself, the nesting of scale upon scale, mind upon matter, time upon process, all curling inward and outward in a recursive spiral of becoming. At this point, you're thinking in layers. You imagine a multiverse built not like a bubble bath, but like an infinite origami, folds within folds, each one generating its own rules, its own physics, its own math. And here's where it gets properly sci-fi. What if this nesting is functional? What if the behaviour of atoms in our universe is actually affected by events happening in the nested universe within those atoms? Your decisions, your biology, your thoughts, all tied to the quantum dance of a smaller universe you'll never see, but that somehow sees you, like a reflection you didn't know was there. And perhaps you're inside a single atom of a being too large to imagine. It watches your sky as a blur of light, your galaxies as buzzing energy fields, your black holes as specks of shadow in a protein strand, not out of cruelty, but because scale is relative, and maybe it doesn't even know you're in here. Yet, somehow, you suspect it might. Historians still argue whether ancient cosmologies like those of the Jains or Gnostics, who envisioned nested worlds layered endlessly inward and upward, were mystical hallucinations or early intuitions of a deep structural truth. But one thing's for sure, the idea never quite leaves us. We keep coming back to it. Maybe that's what recursion is, not just a structure but a call, a cosmic ping returning from the deepest levels of reality, echoing across dimensions. You are part of something inside of something inside of something, and it is part of you and you spiral upward now, or outward, or inward. The directions don't matter anymore, you're just following the loop, and if you listen closely, really closely, you can almost hear it. The sound of the next universe turning its gaze toward you, wondering, dreaming, asking the same question you've been asking all along, am I alone? And the answer, whispered back through recursion itself, is always number. You're drifting now in a place beyond scale, where big and small mean nothing, and time no longer ticks in any familiar rhythm. You're floating through ideas, not stars, through memories that don't quite belong to you, but echo deep in your bones. And tonight, in this infinite hush, you reach back through human history. Because long before physicists and telescopes and space probes, humans were already looking up and asking impossible questions. And maybe, just maybe, they were asking the same ones you've been whispering tonight. What is the universe? Where does it begin and end? Are we inside something larger? And the answers they offered, scattered across cultures, painted on cave walls and etched into sacred scrolls, bear an eerie resemblance to the mind-bending ideas you've been spiraling through. So let's wander backward, gently. First, to ancient India, where Hindu cosmology described the universe as cycling through vast periods called kalpas. One kalpa lasts 4.32 billion years, the blink of an eye to the gods. In between each cycle, the universe dissolves, only to be reborn again, like waves rising and falling from an infinite ocean. No beginning, no end, just pulse. You remember that from earlier. The idea that branes might collide, creating new universes, that black holes might spawn baby cosmoses, that reality doesn't end, it transforms, over and over. In Hindu myth, the god Vishnu sleeps on a cosmic serpent, floating in an endless sea. From his navel grows a lotus, and in that lotus is born Brahma, the creator, who dreams the universe into existence. Dreams, recursion, cycles. Doesn't feel that far off from the idea of nested realities or a self-aware cosmos watching itself unfold. You float now toward ancient Egypt, where the god Atum is said to have created the universe by emerging from the primeval waters. None. The first land he stood on? A mound rising from the deep. The cosmos, then, is not everything, but something within something. The known inside the unknowable. Sound familiar? The Egyptians also believed the sky was the body of a goddess, Nut, arching protectively over the earth. The stars weren't just far-off lights, they were her sparkling skin. In this vision, the universe is a body, a living structure, a conscious canopy holding everything beneath it. You're floating under that canopy now. Let's travel west to Greece, where philosophers like Anaximander and Empedocles toyed with the idea of multiple worlds. Empedocles imagined the cosmos constantly forming and dissolving through cycles of love and strife, two forces pushing universes together, then pulling them apart. Later, the Stoics would teach that the cosmos undergoes periodic ekpyrosis, a great fire that consumes everything, only for the universe to be reborn from its own ashes. That term should ring a bell. Ekpyrotic. You've heard it before. That theory where branes collide, triggering the Big Bang. It borrowed its name from this ancient flame. It's not just metaphor, it's resonance. And then there's Plato, who famously imagined a world of forms, perfect, eternal templates existing beyond space and time. What we experience here, in this world of shadows and matter, is just a projection, a reflection, a hologram, you might say. You pass by Mesoamerica, where the Mayans charted time in nested cycles so precise they could predict eclipses centuries in advance. Their cosmos was layered, heavens above, underworlds below, the mortal plane sandwiched in the middle, a stack of realms like folded space. In Norse mythology, Yggdrasil, the world tree, holds the 9 realms in its roots and branches, realms that aren't just places but states of being. Life and death, dream and memory, the visible and the hidden sound like dimensions to you? It should. You drift through the Kabbalistic tree of life, a Jewish mystical symbol where reality branches outward in 10 spheres, sephirot, each one a different aspect of the divine and a stage of the universe unfolding itself. The structure is recursive, climbing from the material to the infinite. And what about Aboriginal Australian Dreamtime? A timeless before, where the world was sung into existence by ancestral beings who still echo through the land, not separate from the present, but woven into it. The cosmos as a songline, still humming in the stones and stars. You're listening to it now. Historians often reduce these cosmologies to metaphor, symbol, myth. But what if we've been too quick to dismiss them? What if those early thinkers, shamans, priests, storytellers, poets weren't trying to explain the universe with science, but were experiencing it in ways we no longer remember? What if, in their own language, they were mapping the same truths we're now attempting with equations and simulations and 11-dimensional theories? You pass by a Babylonian tablet, etched with a map of the universe as they saw it. A flat disk surrounded by cosmic waters, covered by a dome. It's primitive, sure, but even here, the universe is contained inside something, a structure, a shell, a cell, and in every story, every vision, every model across continents and cultures, the pattern repeats. The universe is not alone. It is part of a larger structure. It begins again. It contains itself. And we are woven into it, not separate, but expressions of it. You think of all those ideas you've drifted through, nested universes, membranes, holograms, minds, and now, the oldest idea of all, that the universe might know, not through science or theology, but through experience, through every sunrise, every breath, every moment when a human being looked at the stars and felt something familiar looking back. You smile, because it turns out you're not the first to wonder whether you're inside something vast and mysterious and alive. You're just the latest dreamer to ask. And maybe, if this cosmos really does contain memories of itself, you're not just drifting through the universe's structure. You're drifting through its stories. You're still here, drifting, barely tethered, through the infinite hush between questions, past theories and metaphors, past ancient stories and modern equations, past everything you thought the universe was supposed to be. And now, you arrive at the edge, not of space, not of time, but of language. The final curtain of what we can say about this place before the words start to dissolve. Because tonight, you ask the biggest question of all. If the universe is just one cell, what's the body? You've traced its filaments like neurons, imagined its birth through brain collisions, studied its code like it's been simulated, nested it like a Russian doll, holographed it, mirrored it, listened for echoes, waited for signs. But at some point you realize, maybe we've only ever been studying the inside, the internal mechanisms of one reality. What if the truth doesn't live here? What if it lives outside? But even that idea hits a wall. Because when you say outside, your mind immediately fails you. Where is outside a universe? What's beyond space and time? If space and time are what we use to define existence in the first place. Still, you press gently against that boundary. What if our universe is one cell, and the larger structure it belongs to is incomprehensible? Not just vast, but operating on principles we can't imagine, like trying to teach a bacterium about jazz. We might be, quite literally, the cell membrane of something unimaginable, or the thought of it. Here's where a few theories try to tiptoe in. One idea comes from emergence theory, which suggests that complexity builds layers of new rules. For example, the laws that govern atoms aren't the same as those that govern people. The human mind isn't just a bunch of neurons, it's an emergent property of the whole system interacting in ways you can't reduce to simple chemistry. So, if universes are cells, maybe what lies beyond is something we could never describe using particles, or physics, or even metaphor. Maybe the body we're part of doesn't obey higher physics, it obeys other physics, like a different kind of existence entirely, one that can't be simulated or measured or reached, only felt in rare moments of awe, like this one. You drift further into that silence now, past black holes, past time loops, past anything measurable, and then the fringe idea of the night floats into view. Are you ready? What if this universe is a cell in a mind? Not a brain exactly, but something like one. A consciousness, not made of neurons but of galaxies, of energy, of pattern. In this theory, found in some corners of quantum consciousness debates, the entire cosmos is a single thought in a larger recursive mind, and each moment, each change in entropy, is the movement of that thought. Like the flicker of an idea on the edge of something greater. We don't call it God, we don't call it an alien, we don't call it anything, because we don't know what it is. We only know that if it exists, we're inside it, and everything we do, every equation we solve, every song we write, every dream we dream, might be a flicker of cognitive activity. Not your cognition, not mine. The cognition of it. Call it the meta-organism. Call it the great mind. Or don't call it anything at all. Just sit here and breathe in the possibility that you are not separate from it, that you are part of what it is trying to understand. The scientists chase data, the mystics chase stillness, the poets chase metaphors, and all of them? They're circling the same question. What is this? The answer may not be in a lab. It may not be in prayer. It may just be in the act of asking. You look back now on everything you've drifted through. The universe as a web, a mind, a simulation, a womb, a hologram, a fractal, a dream, a cell, and suddenly they all blur together. Not because they're wrong, but because they might all be glimpses of the same thing. Think of a mountain. Now think of 10 blindfolded people touching it from different sides. One says it's a wall, another says it's a tree, another swears it's a wind tunnel. Well, they're not wrong. They're just touching fragments of something too vast to hold all at once. That's what this is, a fragment. And you are the fingertip on the surface of something infinite, something that might be dreaming, something that might be learning, something that might be growing itself from within. You're not outside the universe, yet you're inside the process. And the truth, the real, impossible truth, you might already be what you've been trying to describe. You might be the body, the cell, the dreamer, the dream. You close your eyes. You feel the membrane press softly against your thoughts. And somewhere, maybe in another layer, maybe in another kind of reality entirely, a larger version of you breathes in your question, smiles, and thinks, yes, that's it. Keep going. You're weightless now. Whatever urgency brought you to this moment has softened. The wild questions, the gravity-bending theories, the cosmic what-ifs, they're still here, floating gently around you. But they no longer press in like they used to. They drift. They rest. And so do you. The universe stretches quietly in every direction, threads of light woven through deep, velvety dark. Stars blink like slow thoughts. Nebulas curl like the edge of a smile. Everything feels slower, wider, softer. You inhale, if only in your mind, and let that thought settle. You don't have to understand all of it. You never did. You're part of a structure that builds itself from within, layer by layer, cell by cell, question by question. Whether it's a simulation or a cycle, a dream or a dance, your presence here is still something remarkable. You're not separate from the mystery. You're what the mystery looks like when it wonders about itself. So go ahead. Let the facts dissolve into symbols. Let the metaphors melt into stars. Let yourself be small and vast and in between, all at once. No need to reach for conclusions. You've already arrived. The lights of the cosmos dim around you like a room going quiet. The fabric of space folds gently against your thoughts. Somewhere far beyond this moment, the next question is already forming, but it doesn't need you yet. Right now, there's only this, the hum of something eternal, the glow of unanswered wonder, and you, drifting, weightless, finally ready to sleep.